We're going to look at compositions of functions in today's lesson. I have two written here. We've got f of g of x, and then we've got g of f of x. One thing you'll notice is that we have an open dot here that is different than the closed dot we are used to seeing that represents multiplication. Alright, this open dot is what lets us know that we are doing a composition and not just a multiplication, not just a product combination like in our earlier lesson. Okay, so we have f of g of x is how you would say this, and we have g of f of x is how you would say that one. The idea here is we are basically, again, being given two functions, an f of x and a g of x function, and depending on which composition we are asked to do, we are going to be taking one of our functions and plugging it in to x of our second function. So for example, if we are doing f of g of x, what that means is we are supposed to take the entire g of x function and we are supposed to plug that in to our f of x function. Whereas g of f of x would be vice versa, taking f and plugging it into g. The idea is the same as, say, when you've been given just a basic function of f of x equals x plus 3. And then you were probably asked at some point to do something like f of 2. And you were taught that what that means is if you're asked to do f of 2, since you had x in the parentheses here, and now 2 is replacing x in the parentheses, that's the equation's way of telling you it wants you to plug 2 in for x, replace x with 2, and then see what you get. So you would take 2 plus 3, which would give you 5. Right? That's the way that works. If you have f of x equals x plus 3, then f of 2 is 2 plus 3, which gives you 5. On that same token then, if you are asked to do f of g of x, the same way that you knew to plug in 2 because it was inside those parentheses, that would mean you need to plug in g of x because it's inside those parentheses. Let's take a look at an example to show you what I mean. So let's say I gave you an f of x function of x squared and a g of x function of x plus 1. And let's say that I wanted you to find me f of g of x. So understand, if I'm asking you to find me f of g of x, which also, remember, it could look like this as well, but I prefer the first one that I wrote. If you're doing f of g of x, that means I'm asking you to take the entire g of x function and plug it in for x in the f of x function. You're not replacing one function with another, you're taking one function and plugging it in just to x for the other function. Meaning, we're taking this entire g of x function, the whole thing of x plus 1. I want to take that whole g of x function and I want to plug it in specifically where x is in the f of x function. So the squared is going to stay there, it's just the x being replaced. Meaning, another way that we could write f of g of x is we could say we are simply trying to do f of x plus 1. That's really what we're saying we're doing here, f of x plus 1. We are replacing x with the quantity x plus 1. So, instead of x, we would write the quantity x plus 1. And like we said, the x had originally been squared, so what we replaced x with, aka the quantity x plus 1, would also need to be squared. I'll even put that in purple to show where it came from. So that's what we would get from f of g of x. If we have the quantity of x plus 1 squared, that means we would want to take, literally, x plus 1 times x plus 1. So we would want to FOIL that out. X times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. 1x plus 1x is 2x, so we would get x squared plus 2x plus 1 for a final answer here. This time, let's say I give you the same two functions, f of x is equals x squared, and g of x equals x plus 1, but this time I ask you to do g of f of x, which could be written this way or could be expressed this way as well. Whichever way you look at it being expressed, it means we are being asked to take the entire f of x function and plug it in for x in the g of x function. Well, the entire f of x function is x squared, right? That x squared is all we have for the f of x function. So another way we could write this is we're being asked to take g of x squared. Alright, that's effectively what we're being asked to do here. We are taking the entire quantity of f of x, which in this case is x squared, and we are trying to replace that or plug that in to our x in the g of x function, but the x only. So, if we look at our g of x function, instead of x, I'm going to plug in the x squared, and then I'm simply just going to rewrite everything else from the g of x function, which in this case would just be a plus 1. Looking at that, we see that we don't really need those parentheses, so our answer would simply just be x squared plus 1, because there's nothing else to do with that. No matter what composition you're doing, anytime you're asked to do a composition of functions, you're always taking one function and plugging it in for x to the other function. Really all you have to decide is which direction you're being asked to go.